Good day, students. It is super early in the morning right now for me, and I'm deciding to play some music to see how it goes with the lesson. Let me know if this is distracting or not. I need to stay awake, but maybe I'll turn it off next time. So today we're learning about 7.11. This is lesson 7.11 about slicing solids. I want you to do two things after this lesson. First thing I want you to do is to do the Khan Academy activity that I put up on the link above this video. All right, and the second thing I want you to do is do the learning activity after this. This lesson should be okay. Remember, it's just dealing with geometry, using shapes, and we're going to start thinking about how we do it when we slice them. Karen's pretty happy today, but today you should be able to picture different cross sections. We'll learn about what cross sections are, and then you can explain when a three-dimensional figure is sliced, and you'll see the face of the shape of that. So let's start with this warm-up, and basically what we're going to do is just going to look at some shapes here for now. So this first shape we have here, I want you to look at it. What do you see? You can describe it in your head. From my end, I can see that this looks like a pizza. Yeah, not that I want pizza early this morning, but I can see that you have maybe triangles and rectangles connected. All right. So that's maybe the first thing you'll see here. As far as I can see, maybe it looks like some other kind of shape that you could connect with in real life. But to me, it looks like a pizza. Maybe put some pepperoni on that. How about that? There you go. There's your pepperoni. That looks not like it. All right, so this next part, look at this shape. We can see this shape. To me, it looks kind of like a pyramid. And you could also see again, you can see the triangles. And I also see that bottom part, which is probably going to be a rectangle. All right, it's supposed to be this easy. Here's the next shape. It's a little bit more complicated, but this looks kind of like a house to me. You know, if you draw some windows there, nice old windows and a little door. All right, that definitely looks like a house to me. But another way you can see it is you see this shape. What do you call that shape? We call that pentagon. Yeah, it looks like we got that little pentagon thing going on. If I also look at the side, I'm just kind of doodling right now. And that kind of reminds you of rectangles. So maybe rectangles right there. And then you have your base, right? So it looks like you have rectangles, you got pentagons making this house, all right? So this goes to the idea of prisms. We call these prisms. Basically, these are what we call polyhedrons. Poly means many, hedrons means shape, I believe, with two identical polygon bases. So a prism basically has two of the same bases. What we call a base is going to be these parts right here, right? These are bases. And then they're connected by rectangles. Another polyhedron that we just saw, the second part, is a pyramid. And that's when all faces are triangles meeting at a point. So this is my point right here, right? All these triangles are being connected to that. So this is just a warm-up. You've probably seen stuff like this before, but it's just getting you an idea with the shapes. But let's get into the real part, which is cross sections. We're going to learn what a cross section is. First, let's use the example of vegetables and fruit. So some of y'all like to cook. I like to sometimes cook, but sometimes you need to cut up some things like an onion, or if you're trying to maybe do a fruit plate, you might want to do some apples, oranges, and all the other stuff, right? So basically what we're doing is I want you to start thinking with this lesson is to connect, well, what shape do you think the surface of the cut is if I cut, for example, this apple up, right? If I cut the apple up kind of horizontally, what's that face going to look like if you look at that like lighter side, right? Or if I cut it straight up and down, you know, what do we create when we cut up and down, right? Do we create some wedges? What's the face going to look like? Same thing with a carrot. You see this carrot over, I cut that. All right, so we're going to start analyzing what that shape might be. So this first activity is to describe the shapes of the objects, the cross sections, and I'll talk about what the cross sections are in a bit, compare them, and then how do the cross sections compare to its own base. All right, so if the first figure over here You see this, call that a cube, right? It could be like a Rubik's Cube. We can see that we have this bottom part, this base. This is what we'll call as the base. All right, this base is going to be, looks like it's a 2x4, right? So compare the base to the other one. This is also a 2x4, right? That's the same base. So what happens if I cut through it? Let's see if I cut straight in the middle. Right, if I cut straight in the middle of these, what do you think the face or that cut part, right, that smoothed out part is going to look like? All right. So if I was to cut through it, theoretically it'll look something like this. Or again, we're cutting through. You see that blue part? Blue part is like when we're taking a smooth cut, just cutting right through. And then we're going to see that the face of it, this is the face right here. You see that? This is the face. All right, you'll see that those are actually going to be both rectangles. All right, that makes sense, right? When you have this pyramid and you have this cube, cut right through it, it's going to be the copy of that base. Notice how when we cut through, it's going to create a copy of that base, right? These are bases, right? These are bases. All right, we see that the bases are the same and looks like they're pretty much the same. That's what we call what a cross-section is. All right, a cross-section is a two-dimensional figure that is exposed by slicing a 3D object. There's a lot of stuff with this cross-section stuff in the future and higher level math, but the idea is if you have a pineapple, right, it's a very spherical-ish shape. You cut right through that, and then the two-dimensional figure, I like to call it the face or the base, is looking like a circle-ish, circular thing, right? So that's what's happening. When you cut a 3D object, you create a two-dimensional figure. All right. Let's go ahead and start with this last activity before we end this lesson. We're going to start doing more cross sections, and we're going to kind of describe it with what the shapes that we have. So for example, I have here a prism of, you can call it like a rectangular cubish thing, but we'll call it a prism parallel to the bottom and top faces. So again, these have, looking at that base, it's a 4x2 and it looks like it has a height of 3, right? So the question is, what is going to be the new shape if I cut it through? All right, if I do a horizontal cut straight through that prism, okay, what's the top and bottom faces going to be? So the answer to that is, we're going to have is a rectangle with length 4 and a width of 2, right? So if I was to cut this straight in half, you would get two separate rectangles, but you would have the length of 4 and width of 2, right? So this length would be, that length would be 4 and this width would be 2. All right. So let's go ahead and make another cut, and let's go above a little bit. All right. So the plane moves up and cuts the prism at a different height. Do you see anything different about that when we cut through? So I'm just preparing some notes real quick. All right, so thinking about this, when we cut right through, this is what our answer should be. We'll have a rectangle, same thing, with a length of 4 and a width of 2. All right, but notice maybe the height. Notice how the height, this whole thing is 3. Would this height be different compared to this other height? Okay, we could say that maybe the lower part of that cut is going to be a higher height, right? Again, this is very common sense. Like, I want you to get comfortable with this, but this is just as straightforward as that, all right? But the idea is when we cut through, we'll have a face that's similar to its base. Yeah, that sounds good. You have a face that's similar to the base. All right, so what happens if I cut right vertically now? So instead of doing this horizontal cut, I'm doing a vertical cut. Well, if we could do that, we should have a rectangle with height of 3. So that's reflecting this right here. Let me do it in red. This and this, doesn't it? And the width and length of the diagonal base. So we don't know what this length is going to be right here. We're going to call that the diagonal width and length of the diagonal base. All right, you see if you kind of split those apart, that vertical shape, that vertical 3D shape, it looks like you kind of have these like triangular shaped things, right? Maybe pizza stacks. I don't know what to call it. But yep, let's go ahead and go to these next ones. Hopefully this is making sense, right? You cut the shape and you have a figure on that face. So what happens when we do this pyramid parallel to the base? So if we do a horizontal cut that's parallel to the base. So again, the base is right over here, right? Notice how when we cut horizontally, is that shape going to be the same? All right, so your answer for that is you're going to have a square with width and length less than 4. Okay, so I didn't get this set up enough, but it looks like the problem didn't tell me that this is supposed to be 4 and 4. All right, so we'll keep on looking at that. But notice how when we're cutting up, right, the higher we go, so the higher we cut on this pyramid, the smaller that face value is going to be, right? That makes sense is because we have this point up here and we're cutting through, we're going to get smaller, 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 right? So what happens if I do it vertically? Now remember, this is going to be 4. I don't know if the height is given. Let's see. The cube has the edge length of 4. So if I cut vertically, what should happen is you have an isosceles triangle with base 4 and height 4. All right. So what's it saying is, again, this wasn't given to me, but we can say the idea is when we cut through, we have this isosceles triangle. All right. You see that? The isosceles triangle is in red right there. It looks like the height from that isosceles triangle from the bottom to the top is going to be 4 as well. All right. We got 2 more shapes, don't we? So now I got this cube. Let me double check if I know the size of the cube. Yeah, so it says a cube has an edge of length 4. So I think if it's a cube, it should all be 4, shouldn't it? So what happens if I cut that corner off, right? Just take this knife, this sword, whatever you want, lightsaber, and you cut that bottom right corner off, you should get a triangle. All right, so there's that triangle right there. All right, so now let's beef it up a bit. This is kind of cool, right? I want to know what kind of shape do I get if I kind of move that diagonal farther in. So remember, we had that diagonal cut, right? That diagonal cut right up in that corner. What happens if I move that down a little bit to this point? Okay, what shape do you see? Looks like I have this cut right through and I have something like this. So this should give me a hexagon. All right. So let's kind of review with this. So what is a cross section? Cross section is a 2D shape that results from slicing a 3D object. If we slice that 3D object, we get a 2D shape, or we get that face. Sometimes related to the base, sometimes it isn't, but that's what a cross section is. Another question is, what are possible cross sections that can result from a prism that is sliced parallel to its base? So this is my base right here. I slice that parallel. We should say that all cross sections will be the same size and shape as the base. So that was the same thing with that pyramid, right? Or that rectangle. When the rectangle is like that prism rectangle where it's the rectangle on the bottom, but we cut right through, we have the same cross section shape as well. Another question is, can cross sections of a prism or pyramid be a different shape than the base? Well, I think we said yes. Example is slicing the corner off a cube that we saw, that top right corner, then we move it down, right? We cut it on the top, we had a triangle, but we cut in the middle, it turned to an octagon, right? This one right here, we cut in the top, trying to get my size going. We cut out the top right, We cut out the top right, that created a triangle, but when we go deeper in, we create a hexagon. All righty, so we were able to picture different cross sections of prisms and pyramids, and then we're able to explain when a 3-dimensional figure is sliced after we cut it through and what 2-dimensional shape we have. All right, so with that being said, we're done for the lesson. Please do the Khan Academy practice in the very top here. It's really good practice with cutting through and seeing what the shape is. And go ahead and do the learning activity. If you need help, please come to my office hours or send me a GChat email. I prefer GChat. I find that's really easy. And yeah, make it a great day, class. We're almost done.